In this video, we're going to learn how to multiply a matrix by a matrix. Now, let's consider the example we have here. We have a matrix A, which is a 3 by 3 matrix, and we have another matrix B, which is a 3 by 3 matrix. Now, these are simply 3 by 3 matrix because they have 3 rows and 3 columns. So how do we actually multiply this matrix? Let's see how to go about it. So we have matrix A having the elements of 4, 2, 1, 0, 3, 3, 1, 1, 2, and it's multiplying matrix B having the elements of 2, 2, 1, 3, 4, 1, 1, 1, 1. So in multiplication of matrix, we usually use the rows in the first matrix to multiply the columns in the second matrix. So this is what we mean by this. We will use the first row here to multiply each columns that we have here. So we'll use this first row to multiply this column, write the result. We use the second row to multiply this first row again to multiply the second column, write the result. We use this first row again to multiply this third column. So we go like that. So our result will be written in the positions of the row by column that we're multiplying. So this is row 1, all right, column 1. This is row 1, column 1. So it means that the result we're getting from multiplying this by this will be written in the row 1, column 1 position of our resultant matrix. Okay, so when we are done with using this row to multiply each and every column here, we'll move on to the second row. We used to multiply each and every column here. We'll then move on to the third row. We used to multiply each and every column here. So let's just simply see how we go about this. So we are going to use this element 4 to multiply this element 2 here. Remember that we're multiplying row by column. So we use this 4 to multiply 2. Then we'll add the result to 2 multiplied by 3. We'll also add that result to 1 multiplied by 1. And that result will be written in the position of row 1, column 1 of our resultant matrix. So this is what we're going to be having. So we have 4 times 2 plus 2 times 3 plus 1 times 1. So this is our row 1, column 1 position. So the next matrix we are going to be multiplying will be on the row 1, column 2 position. So we use this row 1 to multiply the second column here. So we have 4 times 2 plus 2 times 4 plus 1 times 1. All right, so that would be for the row 1, column 2. Then for the third part, which is this multiplying this, all right, so we have okay, because there's no space, so I'll just actually do the multiplication. We have 4 times 1, that gives us 4, plus we have 2 times 1, that gives us 2, plus we have 1 times 1, and that gives us 1. All right, so we'll be having something like this. Yep. Okay, let me change this. We're having something like this. All right, so just for us to be quick, I won't be actually expanding like this anymore. So since we are done, we're actually using the first row to multiply each and every column, and we wrote the result in the resultant positions. So we'll move on to the second row here, having the elements of 0, 3, 3. We used to multiply each and every column likewise. So we have 0 times 2, that gives us 0, plus we have 3 times 3, that gives us 9, plus we have 3 times 1, that gives us 3. So we're done with that part. So we'll move on to the second aspect. We have this multiplying this again. We have 0 times 2, that gives us 0, plus 3 times 4, that gives us 12, plus 3 times 1, that gives us 3. So we're done. We'll move on to the last part. We use this row to multiply this column. So we have 0 times 1, that gives us 0, plus 3 times 1, that gives us 3, plus 3 times 1, that gives us 3. Now we're done with that the second row of the resultant matrix. So we'll move on to this third row here. I'm going to use to multiply each and every column. So we have 1 times 2, that gives us 2, plus 1 times 3, that gives us 3, plus 2 times 1, that gives us 2. Now we have 1 times 2. Yeah, we're using this now to multiply the second column. We have 1 times 2, that gives us 2. We have 1 times 4, that gives us 4. We have 2 times 1, that gives us 2. We use this third rule again to multiply the third column. So we have 1 times 1 plus 1 times 1 plus 2 times 1. All right, so here is what we have. Now our final answer will just simply be we summing up all these. All right, So permits me to actually write the answer here. So we're having something like this. Okay, our answer. So if we sum up 4 times 2 is 8 plus 6 plus 1. So we have 8 plus 6 plus 1. That is going to give us 15. Then here we have 8 plus 8 plus 1. That's going to give us 17. Here we have 4 plus 2 plus 1. That's going to give us 6. Sorry, 7. We have 0 plus 9 plus 3. That's going to give us 12. We have 0 plus 12 plus 3. That's going to give us 15. We have 0 plus 2 plus 3. That's going to give us 9. That's going to give us 6. We have 2 plus 3 plus 2. That's going to give us 7. We have 6 plus 2. That's going to give us 8. We have 2 plus 2, and that's going to give us 4. So this is simply the result of multiplying this matrix by this matrix. All right. So just a brief recap: we'll multiply the rows by each and every column. Then we'll move on to use the second row to multiply each and every column. So the positioning in the resultant matrix is dependent on the row and the column which you use to multiply. So let's consider this resultant matrix now. This resultant matrix is on the position of row 3. All right, is on row 3, column 3. So it simply means that I use this row 3 to multiply this. All right, to multiply this column 3 to get this. You see? So that's just simply how you go about it. So if you want to learn about the identification of matrix, I'll drop a video here. You can use that to learn the identification of matrix and their positioning. All right. Now let's consider another example. Now in this second example here, we're asked to find the multiplication of matrix A by its transpose. So this A raised to power T here means the transpose of A. So what's actually the transpose of a matrix? The transpose of a matrix is the result you get from interchanging the number of elements you have in the row of a matrix to its column position. So if we consider matrix A here, having the elements of 2, 3, 4, and 4. If we want to get the transpose of matrix A, what we simply need to do is to interchange the elements in the rows of column A to their column position. All right, so 2 and 3 here are in the row position, right? 4 and 4 are in the row position. So we'll interchange this row to be in column format. So instead of it being 2 by 2, 3 here, as in the row, it will become 2, 3 like this in the column. So instead of 4, 4 becoming staying in the row, it will become 4, 4 like this in the column position. All right, so this is really the transpose of this matrix. So we're actually asked to multiply the matrix A by its transpose. So we are having 2, 4, 3, 4, multiplying here this matrix, this transpose here. So likewise, in this case, we have a 2 by 2 matrix multiplying another 2 by 2 matrix. We are still going to use the rows to multiply the column. You understand? So let's do that. We have 2 multiply 2, that's giving us 4, plus 3 times 3, that gives us 9. All right, we move on to the second position. We have 2 times 4, that gives us 8. We have 3 times 4, that gives us 12. All right, now going to the row 2 column 1 position. All right, this is row 2 column 1 position. So we have 4 times 2, that gives us 8, plus 4 times 3, that gives us 12. All right, now I'm moving on to the row 2 column 2 position. That's the final position. We have 4 times 4, that gives us 16, plus 4 times 4, that gives us 16. So our final answer is going to be 4 plus 9, that's 13. 8 plus 12 gives us 20. This gives us 20. This gives us 32. So this is simply our final answer in multiplying this matrix A here by its transpose. So in the next video, I'll still be explaining more on matrix. So do well to subscribe to the channel.
If you would like to see more explanations on other math topics, click on the subscribe button and also hit the notification bell icon to be notified when I make another video. Also check the link in the description to get access to helpful math textbook on my Telegram channel right now.